Warm up number 26, power standard 7 and 8. All right, power standard 7 wants us to write an equation for this table and to always show our thinking. This one's a little tricky. Well, what if I look at what do I do to 2 to get 3? I add 1. But I don't add 1 to 4 to get 7. Is there something we can multiply by? There is, but it's not going to be the same each time. So this one you might have to play around with a little bit. Kind of what I see, if it's not just going to be just multiplying or just adding, we're going to do some combination of the two. So maybe I want to start by multiplying by 2. If I multiply by 2, that gives me 4. And then I can subtract 1 to get 3. So maybe multiplying by 2 and subtracting 1 works. Let's see. 4 times 2 is 8. And then if I subtract 1, I get 7. 5 times 2 is 10. If I subtract 1, I do get 9. So we can say here, to go to x, y, we're going to multiply by 2, and then we're going to subtract 1. But because it's a function, we're going to write y equals, and I'm saying, instead of saying x times 2, we always write it as 2x. We take the multiplication symbol out and write the constant first, and then minus 1. It's a little tricky. Sometimes you have to, if it's not just multiplying or not just adding or not just dividing or not just subtracting, it's going to be some combination of the two. All right, the next one says, take this figure here. We're going to translate it, meaning we know it's going to stay, it's going to preserve the side lengths and angle measures. And we're going to take it 5 down and 4 to the right. So I could just count it out, and I could go down 4. 1, 2, 3, 4, and I'm sorry, down 5. 1, 2, 3, 4, 5, and then go 4 to the right. 1, 2, 3, 4. And I could do that for the few more points. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And in my sloppiness here, we're going to develop a shape that looks exactly the same. Not taking into account human error. So as I always say, just kind of squint a little bit. But it's not going to get any bigger or any smaller. We have our coordinate notation too, meaning we can take a point and apply these movements to it. So x deals with our left to right movement along our x-axis. So if I'm going 4 to the right, that's in the positive direction. So I'm going to add 4 to x. Our y value is dealing with up and down. So if I'm going 5 down, I'm going to subtract 5 from our y value. So taking a point, let's say this one right here, which is the point -3, 1, 2, 3, 4, 5, 6, 7. So if we take -3, 7, and apply these movements, -3 plus 4, 7, sorry about that, minus 5, we would get -3 plus 4 is 1, 2. And somehow I messed up, maybe. 1, 2 would be right here. So let's see